Do you know that Netflix has over 1,000 microservices to support their system? 1,000. Just imagine the pain to deploy each one of them. Fortunately, with CI/CD pipelines, we can automate this entire process, taking our code all the way to production quickly and smoothly. Hello world, my name is Monis, and today we are going to set up a CI/CD pipeline from scratch. But before we dive in, if you're new to the concept of Docker, I highly recommend you to check out my other videos where I cover the basic concepts of Docker to give you a solid foundation. And if you have already done that, then this video will give you a clear understanding of what CI/CD really is and why it's crucial for your projects. And then we will set up a CI/CD pipeline together to build, test, and deploy our code in production environment. And you can download all of the code examples and documentation from my public repository. Link is down in the description. So without further ado, let's get started. CI/CD stands for Continuous Integration and Continuous Delivery. Back in the day, during the era of monolithic architecture, the release process of an application to production used to be this big planned activity. Changes from a lot of different modules of a code base were packed together, and then we had these infrastructure and deployment experts who manually deployed the application on production with some Linux magic. Today, with the rise of microservices architecture, applications consist of various services that communicate with one another. These microservices are usually owned by different teams who are responsible for managing their respective deployments. In addition to this, all of these microservices continuously undergo changes. This is where the CI/CD pipelines came into the picture. First, they automate this entire process of taking your code and deploying it on production. And second, features can go live as soon as they're ready because of this automation. And this is the reason that they're called continuous integration and continuous delivery pipelines, because each microservice continuously ships out features to production. When you think of a pipeline, a water pipeline might come to mind. A city typically has a water treatment plant that sources water from various places like lakes, rivers, and groundwater. The plant treats and cleans up the water, conducts tests to ensure that the water is drinkable, and then distributes it throughout the city. A deployment pipeline is not that different. Developers work on their code, they push it to a Git repository, and when the code is merged to the main branch, the pipeline execution starts. A pipeline consists of several steps. For example, step 1 tests the application if it's functioning as expected. Step 2 builds the application image and pushes it to the Docker registry. Step 3 pulls the image into the staging environment and runs it. Optionally, a test might be run to check if the deployment on staging was successful or not. Similarly, step 4 pulls the image on the production environment and runs it. If any step of the pipeline fails, it would fail the entire pipeline, meaning the next subsequent steps will not be executed. This is to ensure that only stable versions of the application reach the production environment. The pipeline is fully customizable. For example, you can add steps for checking the code quality or notifying your team once the pipeline has completed. In this video, we will keep it simple. Our pipeline will have only 3 steps. It will test the application, build and push it to the Docker registry, and then deploy it to the server. So let's do this process step by step. A GitLab pipeline is written in the YAML format and is named .gitlab-ci.yaml. In this pipeline, we start by defining what all stages we want in our pipeline. This can be specified by the stages directive. We define 3 stages, that is test, build and upload, and then finally deploy. Next, we define some variables that will be used in the pipeline. For example, image name, container name, and such. There are some other variables which are secret. For example, a password to log on to the Docker Hub. These secret variables should be defined separately from the GitLab console in masked form. The details for doing this are present in the description. And now we come to the real stuff. We actually define what actions each of these stages does. Each stage happens in a lightweight execution environment, something kind of like a very lightweight Linux. And in each stage, we specify a base image which provides the command line tools for what we want to execute. Now, in the first stage, we require Gradle to execute the tests, so we specify a Gradle image. In the second stage, we want to build a Docker image and push it to Docker Hub. For this, we require the Docker command line, so we specify an image which provides us with a Docker CLI. We also specify that we want Docker as a service inside this execution environment so that when we run commands through our CLI, the Docker service can actually act on those commands. Similarly, in the third stage, we specify a very light Linux image called Alpine. In this execution environment, we will just access our remote production server. This can be done easily via SSH, so we don't require anything heavy here. These execution environments are called runners in the GitLab terminology. If you come from a Jenkins background, you can relate this term with the term agents. Now that we have specified the base image of each stage, we specify what each stage actually needs to do within the script directive. For keeping things neat, we have created a directory called infra, which houses all of our scripts for each stage. Let's go through them one by one. The first script holds the commands for executing the tests. Depending on your application, this command can vary. Since we are using Java-based Spring Boot, the command to run tests looks like this. In the build and upload stage, we specify multiple scripts. The first script creates a Docker image, the second one logs us into the Docker Hub, and the third one pushes this freshly created Docker image to the Docker Hub. You can also write these commands in one single script as well, but then it's always neat this way. A point to be noted here is that we tag our image with the latest commit hash of our Git repository as per the industry standards. This is provided to us by Gitlab in the form of this environment variable. In the next stage, we want to log into our remote server using SSH, so first we need to make sure that the SSH command line is installed on our lightweight Linux. Next, we use this command line to log in to our production server. Once logged in, we log on to our account in Docker Hub, pull the image, and then run it. We also added the commands to remove any previous containers of the same image in case we are redeploying. Please note that the Docker CLI and daemon must be installed on your production server. Because all this Docker login, pull, and run that we are actually doing on our production server via SSH and not in our runner. Now, we can either run this pipeline manually or merge something to the main branch to trigger it. Once triggered, it will execute the 3 steps one by one. Once completed, it will automatically send an email with the status of the pipeline. After that, we can hit our production server's IP or DNS in the browser and see our app ready for us. And there you have it, your very own CI/CD pipeline up and running. I hope you are feeling more confident about automating your deployments now, whether you're working on a small project or something as big as Netflix and its 1,000 microservices. If you got stuck along the way or have any questions, feel free to drop them in the comments below. And don't forget to check out the repository for all the code examples that we used today. See you in the next video. Bis dann.